right, welcome back. This is the second part of 3.2. So 3.2 video number 2, and we're going to continue talking about domains. In the first video, we practiced learning how to write all the domains, and now we're going to practice how to find them. Let's do our first example. How do we find the domain of a square root function? Here's my function. G of x equals the square root of minus x plus 2. Now let's remember something about square roots. Remember, if we try to take the square root of 9, we can get either plus 3 or we can get minus 3, right? Well, when we talk about a square root function, usually they restrict the domain to always choose the positive square root so that we can work with it as a function. So from now on, we're always going to pick the positive square root when we're computing square root functions. Some people call that the principal or the primary square root. So we're only going to pick the positive one for now. All right, remember, another thing about square roots is what happens if we try to take the square root of a negative number. So let's try to take the square root of negative 9. Well, it's not 3, right? Because 3 squared is 9, so that's not right. And it's not negative 3 because negative 3 squared is also 9. So there isn't a number that you can square and get a negative number. So remember, we don't do square roots for numbers less than 0. We do imaginary numbers, but we're not going to talk about those quite yet in this class. We'll come back to those. So remember, we can only take the square root of a number bigger than or equal to 0. So if we look at our function, g of x equals the square root of minus x plus 2, we really need what's underneath the square root here to be greater than or equal to 0. And that's just a simple linear inequality. We need to solve minus x plus 2 is greater than or equal to 0. Well, let's solve this by adding x to either side. That means 2 is greater than or equal to x. And I generally like to rewrite those with the x on the left-hand side. It just helps my brain a little bit, which is the same as saying x is less than or equal to 2. Oh, I know how to do x is less than or equal to 2. On a number line, that would be, here's negative 2, negative 1, 0, 1. Oops, I need a bigger number line, don't I? 2, 3, 4. If I want x less than or equal to 2, I'm going to color in 2 and go all the way to the left. X is less than or equal to 2. And so in interval notation, negative infinity to 2, and I'm going to include it because it's less than or equal to. So that's my domain for the function g of x. And if I put any number bigger than or equal to 2, I'll always get what's under the square root sign to be 0 or greater, and therefore I can compute the square roots. Let's think about rational functions. What's another thing that goes wrong in math? We can take the square root of a negative number, but another thing that sometimes we really like to avoid doing is dividing by 0, right? Dividing by 0 is not good. It's impossible to divide things up amongst 0 people. So when we're looking at rational functions, we know we have a fraction bar, which is also like a divide sign. So we need to be really careful that this denominator is not equal to 0. So we need to figure out where it equals 0 and exclude it. So when does t minus 5 equal 0? Well, that happens when t is equal to 5. So our domain is any number but 5. Any real number except 5. So let's think about that on a number line. Well, we want, here's 5, here's 6, here's 4. We don't want 5, because we'll draw a circle around it, but we're okay with everything else, right? Let's switch to a different color. We're okay with everything else. So we're fine here, up to 5, not 5, over. So we can go to negative infinity up to 5, and then we use this little union symbol that means also 5 to infinity. Everybody but 5. This one I think is convenient to write using set builder notation. So we write the set of all x such that x is not, t, sorry, I switched my other variable. The set of all t such that t is not 5. So that's another way you could write that. All right, let's do one more example, a quadratic function. Now remember, when you're checking for domains of a function, we're finding the domain of these functions. That's the directions, find the domain of these functions. I should have written that, find the domain. So when we're finding the domain, you need to check for two things that can go wrong. Like in our first example, one thing that can go wrong is you could end up taking the square root of a negative number. So one thing that could go wrong in your domain is to take the square root of a negative number. When we look at this quadratic function, we don't have any square root signs, so we got that one already checked off. We don't have to worry about that. The second thing that can go wrong is like what happened in our example 2, is you got to check for, hey, am I going to be dividing by 0? Well, there's no division sign, there's no fraction bar, so you're never going to divide by 0. If you check these two things, you're not going to be taking the square root of negative number, you're not going to be dividing by 0, then those are the only two things you really need to check for your domains. And if it passes those two tests, your domain is going to be minus infinity to infinity, or another way in words, it's just all real numbers. You can put any real number in there. All quadratic functions have domains of all real numbers. All linear functions, all polynomials, a lot of most functions have domain. I don't want to say most functions. A lot of the functions we work with have domains of all real numbers. You just got to watch out for those square roots, and you got to watch out for those dividing by 0. All right, let's find domain and range from a graph. This is our last example for today. Oh, nope, we have one more. So finding the domain and range of a graph. So let's look at this function. It has an arrow here off to the left that indicates that it's going on forever in that direction. But then it has a dot here at 2, 3. So that indicates that the function stops. So if I wanted to keep drawing this guy, it would keep going on forever and ever in that direction. When we're thinking about the domain, right, we're thinking about the inputs, and that's going to be on the x-axis. The way I like to think about finding the domain from a graph is if I'm traveling along the x-axis from negative infinity out here, and I travel along the x-axis, where am I going to have function values? Or another way I like to think about it is if I just squish the function from top to bottom, it would squish down, right, all the way until x equal to 2. And there would be function values all the way along here if I squished it down, but it would stop at 2. So my domain for this function is going to go from negative infinity up to and including 2. The range is similar except for in the opposite direction. Your range, you're going to think about your y-axis. And if we look at our y-axis, well, it's going to, if we squished left to right, squish, 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 all the way along, everything's going to go along and make function values until, and stopping at 3. So all the way along here, it's like a number line, a vertical number line, all the way to here is going to be my range. So that's from negative infinity up to and including 3. So that's how to find domain and range from a graph. All right, one more special type of function we're going to do right now, and that's a piecewise defined function. And this is a function that is just, well, like the name suggests, written in pieces for different parts of the domain. So you have 3 different ways to compute c of t. If your t value is between negative 5 and 0, you're going to use negative t plus 1. If your t value is between 0 and 5 inclusive, you're going to use t squared. And if t is greater than 5, you're going to use 20. All right, so let's see if we can figure this out. What is c of negative 5? So my t value is negative 5. Well, let's look at our piecewise defined function. And why did I pick this one first? That's okay, we'll start with a hard one. Actually, there is no definition for t of negative 5, because if we look here, t's got to be greater than negative 5, and I don't have any piece that's equal to negative 5, so this is not defined. It's not in the domain. Okay, so the first one we didn't even get to. Let's try c of negative 2 and see if we have any more luck. So my t value is negative 2. Which of these categories does negative 2 fall into? Well, it falls in between negative 5 and 0. So since negative 2 falls between negative 5 and 0, I'm going to use this function here, negative 2 plus 1. So opposite t plus 1. That gets me 3. All right, let's try t of 5. Well, 5 falls into this category because 5 is between 0 and 5 inclusive. So c of 5, I'm going to use this function, 5 squared. and t of 200. Well, 200 falls into the last category, right? T greater than 5. So c of 200 equals 20. Now, people always get confused by this last one because there's no t in it. It's just a constant. That's okay. No matter what we put in, if it's greater than 5, it's just going to spit out 20. All right, so what is the domain of c of t? Well, we know something that's not in the domain, right? Negative 5 isn't. So if we go from negative infinity up to negative 5, we don't have any, is not defined. We go from negative 5 to 0, 0 to 5, greater than 5, it is defined. So we're fine from negative 5. Oops, what did I do here? Hang on, technical difficulties. We start our values at negative 5, but don't include it, all the way up to positive infinity. All right, so that is a piecewise defined function. This is the end of the second videos. If you need something, if one of these topics was harder for you or you need a little more clarification, please go to the My Open Math section that says more videos at the end of this week's lesson, so end of week 1 lessons. And there are extra videos on all these topics that will go into each topic a little more carefully if you need more video. Of course, you can also email me anytime, set up an appointment, and I'll go over some stuff with you. All right, thank you.